What is a linear equation? Well, a linear equation is an equation whose graph is a line on a coordinate system. So if you actually graph it, you actually get a sloped line. That's kind of a crazy idea, isn't it? For example, here's a linear equation. Linear equations usually have two variables, no exponents other than 1, and they look something like this. Now, if you solve a linear equation for y, which is a very popular and important thing to do, this one would look something like this. And this is a really important form of a linear equation, and we're going to show you why today. And it's going to be basically the premise for what we're studying today. So, if you have an equation, a linear equation that's solved for y, and you have y equals some number times x plus or minus some constant, then each of those terms means something, okay? This is called the slope and y-intercept form of the equation. And so we found out that the m itself is actually the slope of the line that this equation represents. And b is the y-intercept of the line. So what do we mean by that? Let's kind of jump forward here. So first of all, the slope of the line is just how fast or how much it's changing. So in this particular equation, the slope is negative 3/4. So if I was to write this equation, I would have y equals the slope, which I just found is negative 3/4 times x, and then the y-intercept, where it's crossing the y-axis, happens to be 5 on this particular problem. Let's try another look here. So the y-intercept, as we mentioned, is the point where the line crosses the y-axis. So this line is buzzing up along like this, and it crosses the y-axis right at the number 4. So that would be the y-intercept of that particular graph. And so knowing that, and if you find the slope, you can actually write the equation. So let's take a look. To put it very simply, the number in front of x, when this is solved for y, is the slope. The number behind x, the one that says plus or minus something, is the y-intercept of the equation. It's that simple. So let's try a couple of practice problems here. As we mentioned, this is the slope is negative 3, the y-intercept is 5. How about this one? Well, the slope in this case would be 2, because it's the number in front of x. The y-intercept is actually negative 1, because that's the number behind x, so negative 1. How about this one? The slope is the number in front of x, which is negative 1/2. So it's got a negative slope. And the y-intercept, the place where this graph would cross the y-axis, is at positive 3. Okay, how about this one? Well, the slope is the number in front of x. So we have a 5/4 in front of x. And then over here, there's no number here for the y-intercept. That means there is no y-intercept, so we just put down 0. And that means that this graph would actually cross right through the origin of the graph as it's going across there diagonally. All right, given the slope and y-intercept right, the equation of the line in slope-intercept form. So now that we kind of know what the slope and the y-intercept are, we're actually going to write some of these equations. So if I have a slope of negative 3 and a y-intercept of 1, my equation will look like this. Y equals negative 3x plus 1. The next one, y equals the slope x, so 3/4 x. And the y-intercept is minus 5, so we put subtract 5 right there. Wow, that's kind of easy, isn't it? Let's try this one. Y equals negative 1/2 x plus the y-intercept, which is 3. This number 4, y equals the slope, which is 7 times x, plus or minus whatever reading there you have for the y-intercept. In this case, it's 0, so we don't even have to write it. Okay, so that's what we're practicing. It sounds like it's kind of straightforward. So So you're going to identify the slope and y-intercept today on your Alex assignment. Thank you very much.